Okay, we got a couple situations right here. We've got two triangles, and I drew this. Now this is horizontal, this is vertical, so what do you think? That is a right angle right there. So what do we call this line? We had a whole chapter where we talked about these things. Well, it's not a perpendicular bisector. It is perpendicular. No, it's not a midsector because it's not hitting them. It's an altitude. Very good. Okay, this is an altitude. Okay, so let's write that down. We're going to do three different things, and the first one is altitude. All right. Now, here's what this thing says. Now, watch. Let's put some letters in here. Let's call this A, B, C, and we'll call this D, E, and F. All right. So this is line segment A. You follow me on that, right? We did this yesterday. All right. Now, here's what this thing says. The theorem says. Let me flip to it, and I'll read it straight from the book. But actually, I'm on the wrong page. I was on the homework page. Where's the new stuff? There it is. Thank you very much. 495. Okay, it says that if two triangles are similar. All right, so these are, I'm given that they're similar triangles right there. All right, so just believe me, they are. All right, because I copied and pasted and then I just hit the shift key and I made this a little smaller. So they are similar triangles. Okay, it says the lengths of the corresponding altitudes. So which ones are the altitudes? Give me the letters for the altitudes. B and E, right. So the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. So proportion. So what am I going to do? I'm going to write a fraction, a ratio, right? So I'm going to compare the altitudes to each other. So how would I write that? B what? Over E. Good. Now it says they're proportional to the corresponding sides. So that means they're going to have the same scale factor as what the corresponding sides are going to have. So list some corresponding sides here. A to D, and what else? C to F. Good. And there's another one I didn't mark. I probably should have. There's also this one right here, right? What do you want to call it? G and H? Might as well go in order. And you could stick G and H in there as well, couldn't you? So look, you know a bunch of stuff about that. Now, what did you have to know about the triangles to begin with? That they're similar to each other. So if you have an altitude of two similar triangles, you can compare the two altitudes to each other, and it's going to be the same scale factor, the same ratio as what the corresponding sides are going to be. Does that make sense to you? All right, we're not really proving it, but it is a theorem. It can be proven. We're just not going to do it in class. Okay, so there you go. Let's do another one. That was altitude. Let's do, and all three of these you're familiar with. I'm just changing triangles just to change it up a little bit. And let's do this. Let's make it a different color. Let's go sunshine. How about that? Let's make this a little bit bigger. Now you don't always have to have the bigger one on the left-hand side. I don't know why I do. I just do. And this one's about right there. Oops. You like the color or don't like the color? Is that what you said? Oh, you were watching Con? Did you watch it, really? What did you, it just came up on the computer? Like, just out of the blue? Con. Yeah, it just came up, sure. Come on, don't worry. You can be a geek, alright? It's not that bad to be a geek. Alright? I'm actually kind of proud of it. I'm actually kind of proud of being a geek. You should take pride in it. Yeah, be a nerd. Be proud of being a nerd. Nerds rule the world, I'm telling you. Okay, let's do this. Here we go. What did I do right here? I tried anyway. I don't know if I succeeded, but I tried to find an angle bisector. Okay, so I tried to bisect that angle right there, and I'm bisecting this angle right there as well. All right. Make sure I did that right. Yep. Actually, I was thinking about putting two arcs here and two arcs here, but really, if they're similar, if these triangles are similar to each other, this angle and this angle is going to be the same anyway, isn't it? So if I bisect this angle and I bisect this angle, it's going to be the same thing. If you look in the book, they put two arcs here, kind of indicating that, well, maybe these angles aren't necessarily equal to these angles, but they actually are. So I can keep it like that. All right. So let's list some things. You want to go in this? How did we go A and B? Is that how we did it? A and B, or did we do all the ABCs over here? Is that what we did? Oh, let's just switch it around. Who cares? It doesn't make any difference. Okay, so we'll call this A and B. Let's use different letters just for fun. What's this? R and S Okay, we'll use X and Y, Q. Alright, so we'll use this one is Q, V. Is that what you want? Alright. And we'll say this one is V. Okay, so now look, this is very close to what we did on the other one. Instead of being an altitude, though, this is an angle bisector. So guess what's true about the angle bisectors? They're going to be proportional to what? What did we say on the other one? To the corresponding sides. That's right. Okay, so it's kind of the same deal as what the altitude was. Okay, these are very, very close to the same. So which one is the angle bisector here? A and what? And B. All right. Now, what are the corresponding sides? Let's list a bunch of them. Let's go R first. R to what? S. Now look, if I'm comparing this triangle on the left to the triangle on the right, I have to stay in that same order. Okay. If I go A to B, I have to go R to S. I can't say S to R. Does that make sense? So if I go left to right, I got to go left to right on all these corresponding sides. So R to S. Give me another one. X to Y. And what's one more? And Q to V. Q. It's a weird Q. To V. There you go. So there are your set of proportions or ratios. So all those are proportional to each other. So of course you know what they're going to do, right? They're going to throw numbers in here. And then you're going to have one of the sides missing, and then you just cross multiply and then solve for the missing side. Right? Isn't that pretty obvious to you? Yeah, I think so. Alright, so there you go. Let's do another one. Like this. So we did, what have we done so far? We've done a bisector, which was the altitude, right? And then we did angle. I said bisector before. I meant perpendicular, right? An altitude. Then we did angle bisector, and now we're going to do the median. Do you remember the median? Actually, let me grab a triangle. Copy that. Put it right there. And I don't know, let's just kind of, we'll make it look like this. Just, I don't know, just to be different. Okay, so now we're going to do, what did I say we're going to do? A median. Right, do you remember what the median is? Let's do a different color. Mint julep, that was a nice green. I used that in my other class yesterday. So, the middle. Okay, so where do you think the middle is? Probably about right. Actually, let's do this. We'll just use it. You can use this with any triangle. I'll just use this. Now, it happens to be perpendicular because it's an isosceles triangle, but it doesn't always have to be. Now, watch. What have I done right there? I've gone from one vertex. You watching? Actually, let's not even go from this vertex, just to make it so you don't always think it's going to be perpendicular. Okay? So you can go from any vertex. Let's go from this vertex. But if it's the median, where are we trying to hit? We're trying to hit the what? The midpoint. Where do you think? About right in there somewhere? Yeah. Okay, that's close enough. All right, and then actually this. Okay, and then we're gonna do the same thing here. Midpoint. That's around in there. It's close enough. Okay. So watch. If this and this are equal to each other, then that thing right there is the median. If these two little segments are equal to each other, then this thing right here is the median. Agreed? So let's put some letters in here again. Let's not go all green here. Let's stick a nice little blue. Alright. So, I don't know. Give me some letters. Give me some initials. J and M. And what do I? Nico. Nico. Creamer. And then Demir. Do we have a B in here? Bradley. And then give me another one. We have a D already. Let's do this. W. Who's W? Would you say a W what? E. E. Okay. All right. So here we go. Actually, these should be lowercase. I should have made these because when we designate the lengths of the sides, technically I should make them lowercase. I made them upper. Who cares, right? So let's do this. What's that? It's a great J. What are you talking about? Okay. Now what is this? This is a median, isn't it? Okay. So the medians, guess what? We did altitude, we did angle bisector. The same thing holds true with the median. So the medians are going to be in proportion, right? The ratio of the medians is going to be the same as the ratio of the corresponding sides. So guess what we can do here? J to what? M. And then what? N to C. D to B. And W to E. You're getting the swing of this, aren't you? All right. Yeah, it is pretty easy. All right, let me do one more. I'm running out of time, so I've got to do this. Tell you what, let me just draw a triangle. Don't leave me just yet. Now look, what's the difference in this one? On all of these other ones, I compared two triangles to each other, didn't I? This one, I'm just looking at one triangle, and what am I doing to this? I'm trying to, well, I'm splitting the angles, okay? So what did I just find? The angle bisector. Okay, now watch this. Watch carefully. Don't leave. If this is A, I'm sorry, let's not even make that A. Let's do this. Let's call this little part right here A and B, and let's call this C and D. Are you watching? So now this angle bisector's got nothing to do with the ratios here, but if I split this and I've got these two sides, these are in proportion. These two segments right here, if I compare A to B, guess what they're going to equal? C to D. Now look, the A is on the top and the C is on the top. The B is on the bottom and the D is on the bottom. Do you see that? There's our ratio. Here's some problems to do. I don't want you to have a boring weekend. I want you to enjoy your weekend with some math problems.
Anyone who signed in at the party table this morning who did not pay for their jeans for $1, sweats for $2, please report to the office.
Ah, we just hit the page 500 mark. Isn't that exciting? We should throw a party.
We should throw a party.
Yeah. It'll be tomorrow, so come on in, and I'll have all these worksheets we can do to celebrate our page 500 of the book. All right, have fun with that. See ya Monday.